Student, okay, welcome to Cikgu Mama KimiA channel. Okay, for today, I will teach about organic chemistry. Okay, with a topic of nucleophilic substitution. Okay, of haloalkane. Okay, enjoy the lesson. Okay, class. Okay, before I start my lesson, okay, I will make some revision here. Okay. Okay, now we take a look. Okay, the species of the inorganic reaction. Okay, which actually the species in organic reaction is contained of three types. Okay, we have a nucleophile, we have electrophile, and we also have free radical. Okay, so now I just want you to differentiate, okay, between nucleophiles and also electrophiles. All right. Okay, so for nucleophile, the example here are X minus, okay, which is the halogen. Example is chloride ion. Okay, another example is we have hydroxide ion. Okay, we have cyanide ion. Okay, and then for molecule, okay, molecule which contain of lone pair, okay, which is ammonia molecule and also water molecule, and this is all the nucleophiles. Okay, for electrophile, which is suka electron, okay, which is must be positive. Okay, example is H plus. Alright, also hydroxonium ion is the same thing. Okay, another example of electrophile is CH3 plus. Okay, and we also have nitronium ion, which is NO2 plus. Okay, for molecule, okay, which have empty orbital, okay, we add as an electrophile, okay, which is aluminum trichloride. Okay, also we have BF3. Okay, also we have SO, 3 sulfur, and 3 oxide. Okay. Okay, so now here is the reaction of haloalkanes. Right, why haloalkane occur the mechanisms of nucleophilic substitution. Okay, for the first thing is because of X, which is halogen, which is very highly electronegative. Okay, so this make that the carbon which is bonded to X, it is a partially positive. So the carbon is a partially positive. Okay, thus it will attract nucleophile. Okay, nucleophile will attracted to the carbon which is partially positive. So X will act as a leaving group. So we can write the equation, okay, like this. Okay, right, so this is the reaction, Rx plus X minus. Okay. So now that's why we can see that haloalkane, okay, its mechanism is a nucleophilic substitution. Okay, and also for haloalkane they have elimination. Okay, but for this time I only focus on nucleophilic substitution. So they have two types of nucleophilic substitution, okay, which are Sn1 and Sn2. Okay, let me know more about Sn1 and Sn2. Okay, here is the Sn1, okay, which is this is the pengetua, okay, pengetua, okay, which is haloalkane is a pengetua. Okay, so Sn1, okay, Sn1 is occur to tertiary haloalkane. Alright, here is how we memorize, how I memorize these terms. Alright, pengetua has three wives, okay, refer to the tertiary haloalkane. Okay, and then so he can marry another one, which is Sn1. So it can marry another one wife in 2 steps. Okay, because of this pengetua is already have 3 wives, so he only can add some more wife, only one wife only. So which is tertiary haloalkane is only occur the Sn1. Okay, so okay, we take a look. So they have a 2 step. Okay, the first one, persuade the wives, which is alkyl halide, to be positive. Okay, which is carbocation. And then the second one is the new wife, which is nucleophile bonded with the 3 wife. Okay, so here is the mechanism. Okay, I want to show you. Okay, here is the mechanism. Okay, for number 1. Okay, for the number 1, that okay, we must form carbocation first. Okay, which is that pengetua must persuade the wife, the 3 wives, okay, which is halide, to be positive. So the first one is a formation of carbocation. For the tertiary haloalkane, here is the tertiary haloalkane. Okay, so this tertiary haloalkane, okay, the first step, it must form carbocation. Okay, let me see here. Okay, so it form carbocation here. Okay, and then Cl minus as a leaving group. Alright, for now, here is a slow step. Okay, for the first step is a very slow steps. Okay, the second reaction in this mechanism is, alright, the new wife, okay, which is nucleophile, will bonded with the 3 wives. Alright, so we can see that for carbocation, right, they have the nucleophile, okay, which is the example here. I give that hydroxide ion, okay, as a nucleophile. Okay, when it will react to the carbocation. Okay, so finally it will form. Okay, now it will form alcohol. Okay, which is tertiary alcohol, and this is the fast reaction. Alright. Okay, so they have 2 steps, okay, in this mechanism of Sn1. Okay, which is the first one is carbocation. The second one is nucleophile bonded, okay, to the tertiary, to the carbocation. Alright. So now, okay, this is the carbocation. Alright. Why? So this is the red equation, which is this Sn1, okay, only involve, okay, which is this slow step. This slow step is only involve the halide only. So that's why when we write down the red equation, it will be red equal to K, Rx, which is haloalkane. Okay, and then the order of the reaction is the first reaction, which is Sn1 only involve 1 molecule only, which is alkyl halide. Okay, and then carbocation is its intermediate. Okay, this one, this intermediate. Okay, carbocation is its intermediate. Alright, and then Sn1 also have 2 steps of reaction. Right, so this is the first, the important thing that you must know for Sn1. Alright. Okay, so this is the Sn2 nucleophilic substitution, which is Sn2. Okay, for Sn2 is only occur to primary haloalkane. Okay, this primary haloalkane, okay, pengetua has 1 wife. Okay, primary kan? Okay, so it only have 1 wife. So he can marry another 2 wives. Okay, because it's only have 1. So it can marry another 2. Alright, so now he can marry another 2, which is Sn2, okay, in 1 steps only. Okay, why 1 step? Okay, be good to a wife, which is halide, and marry the new wife, which is nucleophile, simultaneously. Okay, so, okay, we take a look the mechanism in Sn2. Alright, so first you draw the primary haloalkane first. Okay, here is the primary haloalkane. Okay, so now as we know that Cl is a partial negative, right? And automatically this carbon can act as a partial positive. So this nucleophile will attack the carbon from the back side. Alright, okay, which is hydroxide ion will attack the carbon, which is partially positive from back side. Alright, so now is, okay, be good to a wife and marry the new wife. Okay, so this is the transition steps, okay, in the Sn2 mechanism. Okay, which is the both reaction is occur simultaneously. Alright, so we have, okay, so this is the haloalkane. Alright, okay, so we can see that they have transition step here, which is the carbon OH bond is a partially formed here, and at the same time carbon and chlorine here is a partially break. So we can see that in this reaction, in Sn2 reaction, that these have a reaction involved of two molecule, okay, which is halide here and also nucleophile here. So this is we call as a bimolecular nucleophilic substitution. So this is the transition state lah. Alright, which is slow step, and then finally the product form is alcohol. Okay, primary alcohol. Okay, so now here is the reaction. Okay, but now, okay, when we want to write the rate equation, so we can see that rate equal to K halide and nucleophile, because in this reaction it's only have one steps, okay, which is only involved of two molecule, right, which is we involve halide and also we involve nucleophile, and that's why this is the second order reaction, okay, which is Rx, halide and also nucleophile. So second order, and it also have transition step, which we also call as a activated complex. Alright, hence, okay, for Sn2, okay, it have one step of reaction only. So you can see that this pengetua is very happy because it only have to be good to his wife, and he can marry the another two wives simultaneously. Alright, so which is it can form in a one step only. That's why it's very happy. So this is the Sn2. Okay, this is the effects of the structures of a haloalkane, okay, on the reaction rate. Okay, if you can see that this graph, right, which is for primary, secondary, and tertiary of haloalkane, that is decreasing. Okay, Sn2 is a decreasing. Okay, while for Sn1 is a increasing. Okay, why it is happen? Okay. So we can see that this is the tertiary haloalkane, right? This is the tertiary haloalkane. Okay, so you must remember that this pengetua is a sour phase because it has two steps. It consists of two steps to occur the Sn1. Sn1, which is only can marry another one wife only. So it has sour phase because it has to persuade is all wives. Alright, so now, okay, this is the nucleophile, which YSN1. Okay, YSN1 is only involved one steps only. Alright, the first one, okay, this is we call as unimolecular. Okay, which is Sn1. And for this Sn1, okay, if you can see that the carbocation of tertiary carbocation is the most stable carbocation. So that's why, okay, this is we call as a steric effect. For this steric effect, okay, the presence of bulky alkyl group, which is carbon in a C and Cl, is a shielded. Okay, these three alkyl group are shielded the carbon from attack by the nucleophile. So this is what we call as a steric effect. So it's avoid that OH, which is nucleophile, to nearby the compound. So that's why that this tertiary haloalkane, okay, only involve one molecule in mechanism. Okay, so it only involve one molecule, which is Aki highlight, okay, information the carbocation. Alright, so hence for tertiary haloalkane, okay, its higher tendency is a very reactive to occur Sn1, which is higher stability and higher reactivity to react in Sn1. So we take a look for Sn2. Okay, Sn2, this is occur only to the primary haloalkane. Okay, for primary haloalkane, we can see that, okay, when they have nucleophile, okay, nearby the haloalkane, so here you can see that this pengetul is very happy. Okay, so now that this is bimolecular, which is Sn2, okay, bimolecular molecule, which is for Sn2, the reaction is involved of two molecule. Okay, we have Aki halide and also nucleophile. Okay, we involve of two types of molecule. That's why we call as a bimolecular. Okay, hence that when nucleophile, okay, react to the haloalkane, so what happen is it will partially break and partially form. Alright, so it occurred simultaneously. Alright, because they have no steric factor here. Okay, only have one alkene halide, only one alkene only here, so they have no steric effect. So OH minor, which is nucleophile, can attack the carbon here. Right? So they have only one step. Okay, so for primary haloalkane, higher tendency to occur Sn2. Okay. Right, so which is for Sn2 is higher stability and higher reactivity to be occurred for primary haloalkane. Okay, this is the order of reactivity. We can conclude that for Sn1, higher reactivity to occur to tertiary haloalkane, followed by secondary haloalkane, followed by primary haloalkane, and followed by methyl halide. Okay, hence for Sn2, okay, is higher reactivity to occur to the methyl halide, followed by primary, secondary, and tertiary halide. Alright, so higher tendency for Sn1 is a tertiary haloalkane, okay, while Sn2 is a methyl halide or primary haloalkane. Alright, so I hope that you can understand of Sn1, Sn2. Thank you.